Our particular structure, we've got obviously department managers, but we've got account managers that we actually have available to go out and meet with people, to actually sit down and talk about what the program is and what the applications are and what the criteria is. That gets communicated then to our program managers internally, and they go through and basically handle all the specific details once that scope is defined and make sure that production understands it. Because the same difficulty we have getting that understanding from the customer, our guys on the shop have that same difficulty understanding. They see thousands of different parts and designs every year. Trying to understand which one's trying to do this or that is difficult for them. We don't want them to have to try and figure it out. We want them to have a point of reference for quick resolution. Because time is critical on this. So we're trying to move it through. They take care of getting it down to the production cells and those. Again, with these limitations, we know we've got file quality issues. Size. How many people used to have difficulty sending a couple meg file? Well, do you just put it on an FTP site? Open FTP site? Well, what if you've got security requirements? Now you can't necessarily put it on anything open. You've got to separate your password. You've got to encrypt your file. You've got to put them up in the secured areas. The size of the part also impacts whether it has to be built in one piece or multiple pieces. Are there bonding and assembly options available? That 12-foot long piece was bonded together with pins and bolts. We've done others where we bonded them with epoxies and a variety of different other materials, or even the same native material. The orientation of these parts, if you look at this one here, I kind of love how they did this, because really they're twisting the arm that's causing the flex here. It's not bound in the other spot. By doing that, they're utilizing the orientation of the material to give it that twist. If they would have built that in the upright position, the probability of it just bending and flipping right off is high. At the Loughborough or the RM conference that I was at, where they were handing these out, literally, of course, we're all sitting there at the table playing with them and everything, and a couple of them broke during dinner. So we know that there's a fatigue cycle that they're going through. But exactly what that is and whether that was repeatability of the equipment, we don't know. So orientation is a big factor. Accuracy, what level of accuracy do you need? If it's just a basic, simple geometry, it may be better to look at one of these lower end Cubifies or MakerBots or something. A lot of people ask us, why don't we run ABS? Our machines can run ABS. And we basically tell them, well, if you look at the test data available on the ABS from the FDM system, it's really down here versus where your ABS is here. So if you've got an ABS that's really underperforming by about 75 or 25% underperforming, you go with the polycarbonate and you're about 25% overperformance. So you're going to be actually closer to a production ABS injection molded part with the polycarbonate that comes off of the FDM versus the ABS. The other issue is a lot of the smaller systems run ABS. We're not trying to compete. We don't add value when it's just building a cheap, simple part. We'll literally tell people, hey, you can go to Solid Doodle and buy a machine for $500. They can do PLA or ABS. Go ahead and get one. Put it in there next to your engineers and let them build parts. And if they don't build a design before moving it forward, tell them to go back to the drawing board. Tell them to scrap it. Because there's things you can learn. You may look at it and you say, yep, it confirms everything I thought. But the one time you look at it, you say, oh, geez, no, this is way too tight. I'm never going to be able to get this in. How much time can you save? Cost? Yeah, okay, you save a couple of bucks. But when you've got an entire manufacturing line coming on and one part's going to hold it up, has anybody ever had a problem getting everything to come together because of one part? Nobody? Yeah, well, then you may have only made one part. But these are all real factors, and how do you make sure that all comes together? In the scheme of things, time is something we can never get back. And I can tell you, on the Friday before Labor Day or Memorial Day, nobody wants to be sorting through a problem. They want to get out, they want to go on vacation, they want to enjoy time with their family. So, then you've got material properties. There are literally hundreds of additive materials out there. How do you know which one to look at to get the right properties for your part? If people don't look at all the different materials out there, You've got SLS materials with 78300 tensile strength, even though the majority of them are in 4000 tensile strength. You've got SLA resins, which are relatively in a similar bandwidth. Getting the right properties is a big factor. Do you need flame, smoke, and toxicity requirements? And how does the orientation affect them? Which one of these has long-term residual effects? Anybody seen SLA used in direct manufacturing? Anybody seen SLS used in direct manufacturing? The key reason SLA isn't used is because of thermoset materials, and just the chemistry states that it will continue to change properties over time. And it's not UV stable. So if that's going to happen, how long until you have failure? Nobody's going to go through and test to find out how long until you have failure. You know, it won't work. It's only a question of when, so no need to try it. And then delivery. Take a look at what the throughput options are, how quickly you can get parts turned around, how many pieces you need, partial deliveries. Partial shipments on larger quantities is an excellent way to be able to get what you need. First article approvals, PPAP, a lot of these options are available if they're requested. It's really just a question of saying, hey, no, build the first one, put it on hold. You know, give me a 2-day window to get back to you before my delivery gets compromised, and I'll get you a response.